Hello everyone. So today's Leetcode daily problem is minimum falling path sum. This is a medium category problem. The question statement is given an n cross n array of integers, that is matrix, return the minimum sum of any falling path through matrix. A falling path starts at any element in the first row and chooses the element in the next row that is either directly below or diagonally left or right. For more clarification, it is saying that the next element from position row comma column will be row plus 1 col minus 1. This means this can go to this can go to this row plus 1 comma col. This means row is increasing but column remaining same. In this, row and column both are increasing, so this can go to this. So the question statement is clear. Now we have to select the path with minimum falling path sum and we have to give the sum as output. So first of all we will understand how can we approach this problem. Okay, so we are given a matrix of 3 cross 3 in the first example. This is 2, this is 1, this is 3, this is 6, this is 5, this is 4, 7, 8 and 9. In this we have to select the maximum falling path sum. In this we have different number of ways by which we can select it. The question statement as it is given to us that if falling path starts at any element in the first row, this means we can choose any element of the first row. We have options to choose any element in the first row. So we can choose two, either one, or either three. But if we choose the minimum sum, suppose we look this problem greedily, if we choose this, then we can go to this. But in some other examples, it can happen. Then if we choose one, but here are the maximum numbers, so our minimum falling path sum will be maximum. And in this row, at any other column, some minimum value is there, so we cannot do this question greedily. So we have to consider all the cases. We have to apply all the cases to consider the minimum falling path sum. So we have to consider all the cases. First we will consider this, then from there we will go to 6 or 5. After coming to 6 we will explore other possibilities. From 6 we can go to 7 and we can go to 8. From 5 we can go to 7, we can go to 8 and we can go to 9. So we have to approach this problem as you till now you have got the intuition that we will apply recursion because we need to check all the possible cases for the minimum falling path sum. The greedy algorithm will not be useful here. So we will define a recursive function. In this recursive function we will pass the row, column and the matrix. In this, the edge cases are if I equals to n. This means n is the matrix size. Okay. If I equals to n, this means our end condition arise and we have to return 0. Okay, now we have to check if now our answer, we will have to take a answer variable. Suppose we are at these positions here. We will have to take that answer. This means we have to consider this matrix of ij and call this function recursively on the directly below call I plus 1 comma j comma matrix. Okay, now we have to check if our column is greater than 0. This is the most important condition we have to check. Then our answer will be minimum of the answer value which is previously stored from other recursive calls. And now we will consider, in this case we have considered the down, in this case we have to consider the diagonally, we have to consider the diagonally left case. So we'll call this. Okay, now we will have to check that if j is not equal to, if j is not equal to n minus 1, this means j is not in the end row, then answer equals to minimum of answer comma, we will now call this function on the diagonally right, pass this matrix. Now we just have to return the answer. This is our recursive function. Now I will explain to you with the help of an example. We have, firstly we have three options. We can call this function, this function, we have 0, this and this. We have three options because we have three elements in the first row. Now for this we have what options? We have f of we have f of 1 comma 0, and we have f of 1 comma 1. Okay, understand? For this we have what options? From here, this is f1 comma 0, so we can go to f of 2 comma 0 and f of 2 comma 1. From here I can go to, this is 1 comma 1, so from here I can go to f of 2 comma 0, f of 2 comma 1 and f of 2 comma 2. Now from here I equals to, this will call the f of 3, but f of 3 is a return condition, so 0 is returned. Now we will consider the minimum value of these two, this is returned by this, and the minimum value of these three, will be returned by this, and the minimum value of both these will be returned by this. Now we have to take the minimum value of all these elements in our final answer. So I hope you have understood the logic and the algorithm behind this question. So first of all, we will code this. First of all, we will write the recursive function. We have to pass the row and column and our matrix. Okay, we have to pass by reference so that no copy of this matrix have been created in stack. Now our edge cases are if I equals to matrix dot size, then we have to return 0. Now we have considered a answer. In this answer we will add the present element and call this in the below, because below condition will be true for every element, because from everywhere we can go to its below element from there to there. But for right, diagonally right and diagonally left, we have to check the conditions, because these are the edges. Here we cannot go to diagonally left, and here we cannot go to diagonally right. So we have to consider these cases. We just have to pass the matrix here. Now we have to check if j is greater than 0. If it is, we will store the minimum value of previous answers, and we will call this function to its diagonally left. Okay. Now we have to check if j is not equal to matrix dot size minus 1 that I have explained to you. We will store the minimum value of previous answers, and we will go to the right column. Okay. Yes. Now we have to just return the answer from here. Now, to store our final minimum value, we need to take a variable. In this, we will store the int max. Now, for every column of starting row, we need to call this function recursively and store the minimum value in our final answer. Okay, so we will store the minimum value of mini in this final answer, and we will call for every column of the first row. Okay, we have to pass, and now we need to return this mini. It is giving wrong answer. Why it is giving wrong answer? Okay, so I have no, here I should add the values also, because without it it is useless. We have to consider that element, and then we have to call for next options. So now it should run fine. It should run perfectly fine. Yes, it is getting accepted. Now we'll submit this, but this will give us TLE, because we have used recursion, and as we know recursion uses much more stack space and much more time to calculate each value repeatedly. To avoid calculating each value repeatedly, we have to use memoization. So we will make a TP matrix. In this remember we have to take some larger value, because this matrix can also have negative elements from -100 to 100, so we'll have to take a larger value. Okay, here we have to define that n is matrix dot size. Simple. We have to pass this TP here, and we have to pass this TP in this function also as a parameter. Remember to use this DP, pass this DP by reference. Okay, now I just have to pass this DP in every function call. I hope you are understanding every step, as this is the memoization which we have done previously also in one question. Now we have to check if we have calculated this TP or not. If we have calculated this TP previously, then we need not to calculate that. Okay, if we have calculated this TP previously, that means its value is defined. This not the default value, then we will just have to return, and here we will have to store this answer in dpij and return it. It should run fine. Yes, it is getting accepted also, and now it will give accepted. Okay, so this is a medium category problem according to me, and this is the code of this question. Thank you everyone and have a nice day.